Right. So in this video, we will look at triangular inequality. Triangular inequality, you have seen this already. We have proved this using algebra. States that z1 plus c2. So the modulus of a sum of two complex numbers is less than or equal to the sum of the modulus of the two complex numbers. This we proved. So we're going to prove this using the construction. So how do you go about doing it? Is that so you have to construct uh, two complex points z1 z2 plus the addition. So using this construction, we're going to prove it. Now you can see here that I'm going to name these 3 points. This is p1 and p here and p2. You can see that op2p forms a triangle. op1p also form a triangle. So this side is equal to this side, not because this is a parallelogram. Now given a triangle, you know this, that one side is always less than or equal to the sum of the other two sides, which means one side, let's say a, is less than or equal to c plus b. But according to this diagram you know that this is only less than. But in a general case, sum of the two sides is always greater than or equal to the third side. Okay, we're going to implement this idea here. Now let's look at OP1P triangle. In this case, let me take OP. OP is this side, and OP1 and P1P is the other two sides. So definitely you know that OP is less than or equal to OP1 plus P1P. OP1 plus P1P. Now what is OP? OP is a length. So what is a length in a complex plane mean? So length in a complex plane means the modulus of that complex number, if you are taking it with reference to O. So OP is the modulus of Z. So how do you obtain modulus of C? Modulus of C is Z1 plus C2. So we have to mention here that Z is obtained, this point is obtained as C1 plus C2. So modulus of OP, Z1 plus C2 should be greater than or equal to OP1 is the modulus of C. What is P1 and P2? P1, P2 is equal in length to OP2. So this is Z2, right? So you can also call this Z minus Z1 modulus. Z minus Z1 modulus. Let me not say that here, otherwise it will be confusing. So this is one of the this is the triangular inequality, and we'll look at another property here which is very important. Now okay. For this next property, I'm going to use the same triangles, either this one or this one. Earlier we saw that this side is less than or equal to the sum of these two sides. So I can represent this side using the same inequality. Let's say Z1. This Z1 should be less than or equal to, look at the triangle here, OP plus P1. So OP is Z1 plus C2 modulus. OP is Z1 plus C2 modulus plus this one is C2 mod, right? Okay, the same way, let me erase this. Same way, we can think about this side. Write the inequality to this length or this side of this triangle. Let's take OP to P triangle Z2 is less than C1 plus C2 plus Z1, right? So we can come up with these two relationships. This is 1 and this is 2. So I'm just gonna erase this for the moment because we got what we need. Now we can simplify 1 and 2 further. I'm gonna say Z1. I'm just gonna take this C2 to the other side. Z1 minus Z2 modulus is less than the modulus of the sum. Look at here. This one also means Z2 minus Z1. Z2 minus Z1 is less than the sum of the two complex numbers, or the modulus of the two complex numbers. Now what I'm going to do here is that I'm going to take a negative sign outside and multiply it by multiply the complete inequality here. So if I take minus outside, I get Z1 minus Z2, right? The portion changes, inequality stays the same, and I'm going to multiply by minus 1 both sides. That will give me, now the inequality changes its direction, minus C1 plus C2 modulus. C1 plus C2 modulus. Right, so we don't need this anymore, and we don't need this part as well. We have two relationships. First one says this quantity C, the subtraction of these two complex these two modulus, the same quantity is written here. So one relationship says that this quantity is less than this value. The other relationship says the same quantity is greater than the negative of this value, So we can write it in a double inequality, like, so I'm gonna make Z1 minus Z2 the subject here. So this is less than, using this relationship, Z1 plus C2, and this one is greater than minus of that quantity, right? So what do we get here? Now let me erase this. So this is the relationship we need. Says this quantity is less than this quantity and greater than the negative of this quantity. Okay. As you can remember, when we're dealing with inequalities of modulus signs, say that if a modulus of a number is less than a, which means the x or this number should lie between plus a and minus a, provided that a is positive. Provided that a is positive, x should lie between a and minus a. So you can do a little doodle and see how we can obtain this relationship. So we can implement the same idea to here. So now, so you can go either ways. You can go from here to here or from here to here. Now you have obtained this relationship. The modulus gives you always a positive value. So now think of this as a. Here you have a and minus a. So you can write this double inequality in a short form such as the modulus. Now we are going this way. Put this value inside a modulus. So modulus of the difference of these two modulus should be less than the modulus of the sum. Okay, this is the other relationship you obtain. Good. Now you can see here that we obtain two triangular relationships. Let me write it in summary. So this is how you prove it. So we'll write it in summary. You obtain that C1 plus C2 modulus is less than the modulus of C1 plus C2, and you saw that this modulus is greater than, this is greater than the modulus of the difference of the two modulus. Now it's difficult to say it. Here you have two modulus, two types of modulus. There's a difference in modulus inside a modulus. Now the important thing that we can derive from this is that this point is very important. The point is that the sum of the modulus of two sums, modulus of the sum of two complex numbers, has a maximum value and a minimum value. So this gives you the minimum value. This will give you the maximum value. This is what you have to remember. Now let's do an example. Suppose that z1 is 4 plus I and z2 is 3 minus 4y. Let's take these two value. Now if someone asks you what is the greatest and least value of the sum, if someone asks you find the greatest and least values of z1 plus z2, the modulus of c1 plus c2. From theory you know that c1 plus c2 is less than the sum of the modulus. So here the modulus is 4 squared plus, so square root of 17 plus here 9 plus 16, so this is 5. And the least value, since the modulus will always give you a positive value, that's why we have the modulus here, and the subtraction between the two, or the difference between the two modulus, says root 17 minus 5, root 17 minus 5. So this will give you a negative value, but the negative value will cancel off due to this modulus. So in this case the minimum of z1 plus c2 mod is the minimum. This could also be equal to this minimum 17 minus 5. I'm not going to simplify this because this is in square root, and maximum of this is root 17 plus 5. Okay, thank you for listening.